I'm back with you, grade 11s, on the physics exercise 3 on page 34. The homework you had to do in this exercise involved 3 parts. A was to draw the force diagram. B was to identify the type of friction, and C was to write down an expression that you could use to calculate the friction if it was possible, or give the value of the friction if that was possible with the information that you could give, that was given. So in number 1, they say Norco tries to push a heavy crate across a carpet with a force of 60 newtons. The crate does not move. So we identified the friction as a static friction, and the applied force was a 60 Newton force. Now, while the crate does not move, the static friction equals the applied force. It will just be in the opposite direction. So the value of the applied force is 60 newtons, therefore the value of the static friction is 60 newtons. And if they said, yes, they said calculate the magnitude, so in this exercise they did not test the direction, the vector as a direction. They only wanted the magnitude. But I will include here opposite to applied force direction. Now the way I drew the sketch, the applied force was to the right, then the friction would be to the left. Question 2, they say Norco pushes harder with a force of 70 newtons and the crate is just about to move, and we identified the friction as the maximum static friction. Once again, it's a static friction, so the maximum static friction would be equal to that applied force at the point where it will move, so it will be 70 newtons. Now I'm going to take it further from here, just to use the example in order to that we can use to calculate the static friction maximum, and that is related to the normal force. The fact that this is related to the normal force. Let's see how far we can get here. We already know that the static friction is 70 newtons from that expression. Let's see what we can do with that. 70 newtons, mu s, and the normal force in this case is equal to the gravitational force because there are no other forces with components in the perpendicular direction. So mg, 70 equals mu s times, and I think we've already calculated this, 50 times 9.8 is 490, and for the first time in my presence we get that we have enough information to get the coefficient of static friction. 70 divided by 490 gives us 0.14. The 28 is rounded down to 14. Brand new. This is one of the few quantities that will have no unit, because technically that is the ratio between Fs max, which is measured in the Newton, and the normal force, which is measured in the Newton. So this quantity is determined by the types of surfaces in contact. This was just a little bit extra to show you how things can fit together. Question 3. Question 3, Norco has increased the force to 85 newtons and we've got the crate moving. Now this 85 newtons is more than the maximum static friction for the two surfaces. So this kinetic friction will be quite a big thing. This object will accelerate. If a 70 Newton force will start the motion, then the 85 Newton force applied will accelerate the crate. So a way to calculate the Fk, and I don't think we can't say that Fk will be equal to Fa, because that Fa must be less than the Fs max. It's not allowed to accelerate the crate. So this Fk must be less than the 70 Newton force, and we don't have enough information to calculate Fk, but there is an expression that we can write down. The mu k times the normal force, but this mu k is unknown to us. We don't have the kinetic coefficient of friction, but we have the normal force. It is 490 mu k. This is how far we can get with an expression for the kinetic friction in this situation. Question 7 is next. Question 7 says Emron rolls the cricket pitch with a roller mass 200 kilograms. The handle of the roller is at an angle of 30 degrees to the horizontal when the roller is pushed across the cricket pitch at a constant velocity. You see there? The difference between question 7 and question 3 is that they would be at a constant velocity, where in question 3 there was an acceleration. So if that is the case, the kinetic friction will be equal to the applied force, but this applied force has a component parallel to the horizontal surface. You see, the applied force here is at 30 degrees, a pushing force at 30 degrees, and the applied force with its component parallel to the plane, that force will be in equilibrium with Fk. So the Fa parallel is Fa cos theta, and that would be, now we don't have an applied force, the value of the applied force is unknown to us, so it is Fa cos 30 degrees is up to where we can go here. Another way to get this is to use the normal force. Fk would be mu k times the normal force, and in this case the normal force would be equal to the Fg and the FA's perpendicular component. So that would be mu k times 1960 plus, and we don't have the value of FA, sine 30. So there you have two expressions that we can use to work towards the kinetic friction in question 7. Question 8, I think the only thing that changes is that the applied force is a pulling force. The applied forces parallel component will be in equilibrium with the kinetic friction, so the kinetic friction would be equal to FA cos 30 degrees. We don't have a value for FA, so that's how far we can go with that one. Another way to get there is to use the coefficient of kinetic friction, which we don't have either. But in this case, because the applied forces y component or perpendicular component is in the same direction as the normal and opposite to the gravity, we have the gravity, which is 1960 minus FA sine 30 degrees. Right, so two expressions to get FK. That brings us to the end of marking these homework questions that you had. Thank you for watching.